can I change the frequency for sniffing? Like we have right now a problem in two frequencies.
Okay.
So I want to sniff with the probe. I want to see only that component.
Just assume that the probe is connected and you have two ways to check for any changes, what you did if you do some manipulation in the PC board. One is if you go to the operation of the receiver. You see you have the receiver mode, you have the spectrum analyzer mode. If you go to the receiver mode, if you run a scan, it will tell you something what happens at certain frequencies, and it sits on each of the frequencies for this time it's 100 microseconds. Okay, so you just get a snapshot of what happened at that certain frequency. In order to get an idea what happens at that switching frequency all the time, you have to change the display mode to split screen. That gives you the chance to see what it actually measurements at a certain frequency. The frequency is given to 1 gigahertz right now. Okay, in order to change that frequency, you have two choices. First is just press the frequency button and dial in 500 megahertz. So it sits at that 500 megahertz right now and measures the peak value or the quasi-peak value. That's that bar over here, and it gives you the value over here. The second chance is if you have...
How you can display all the three?
Okay, you go to receiver mode, you go to detector, and quasi-peak is highlighted. You can also ever highlight average, and you can highlight whatever you want, maximum peak. Once you do that, it will remain there. Okay, let's go back to the curve. If you have some nice valleys and hills on your curve, you can go to the marker mode, and you can move the marker, what's actually this guy, to the hill that you want to see. Let's assume it's over here. Okay. Then you can press the marker button, and for some stupid reason, you have to press that button twice. First, second, so it's highlighted again. Once that happens, just look how the frequency moves if the cursor moves. So the cursor and the measuring frequency are actually the same. So if you find a hill, just search around and you'll find the actual value that happens at that frequency.
Using the sniffer, we do the same thing, but we connect the sniffer here?
Yeah. And the problem with the sniffer is there's supposed to be a very low signal. And the problem with this guy is you cannot get the whole dynamic range with just one setting of the receiver. And the problem is how to set the amplifier and how to set the attenuator of this guy. And sometimes, not now because there's no signal, there will be a little red light that tells you IF over range or something like that. If that happens, the measurement is not accurate, since some part of the signal chain is overloaded, and sometimes it's the interference frequency. If that happens, you have to reduce the amplification by putting in some attenuator in the system. And I will show you what's the difference in between the different amplification modes the guy is doing. If you go to sweep mode, if you go to scan table, you will get an idea about what is done in the frequency range you are doing. Right now we are in the 30 megahertz up to 1 gigahertz range. Just go down to that values. And you see there is an RF attenuator that is set to 10 dB. Just remember where the curve sits right now. If you go to a higher value here, oops, press enter, and you can see the changes. Go to 40 dB. Okay, it's done. And we run the curve again. See what happens?
It gets
It tells
pushed
you
up.
you have a much higher noise floor in your system that is high above your limit line.
Wow.
That's the reason why you should bring the attenuation as down as possible. But if you want to measure some certain frequencies, you have to bring the attenuation up in order to measure that frequency, since the value is pretty high. There's another thing, and that is the amplifier. There's another setting over here. Let's go to 10 dB. Oops. Again. There's no way to go below 10 dB. There is a way, but it's not good.
Why didn't make them all 10 dB then?
No.
Because they're in series.
For the conducted measurement, 20 dB is a good value, because if you pick up some high values for the EMI, then the overload will not come up. If you put 10 dB in here, that will happen very often. So it gives you some wrong idea what's the level of high EMI if the light comes up and that there's some overload in the system. So you have to play with all those numbers. And the thing is, if you use the antenna, and I think also if you use the sniffer probes, I'm not sure, we have to test that, then it's not enough just to set the attenuator to a value of 10 dB. You might also need, and just keep that setting, and I will run the scan again to show the difference. See where it is right now? It's over here. And then you can set the amplifier to on, preamplifier on. Okay. Go to the scan again and run it again, and it's lower. But you're always endangered that when you have a